Euclid's first light. If you've loved the latest James Webb Space images, you need to see what I'm about to show you. ESA's Euclid Space Telescope has sent back its first batch of images, and they're some of the best space pictures I've ever seen. Known as Euclid's first light, this photo collection is a dazzling tour of the universe's galaxies, and scientists are freaking out at what they're seeing. Euclid's photos call into question our ideas on how the universe evolved, give new insight into the role of dark matter in structuring the cosmos, and even let us peer into the past by capturing galaxies 10 billion light-years away. Plus, the photos themselves are just awesome, especially the last one. I'm Alex McColgan, and you're watching Astrum. Join me today on a tour of what Euclid has captured so far, from glistening galaxies and swirling nebulae to star nurseries and even rogue planets. Let me show you why Euclid is such a unique telescope and how scientists plan to use its data to unlock the origins of the universe. What is Euclid? On July 1st, 2023, the European Space Agency launched the Euclid telescope from Cape Canaveral, Florida. After traveling about 1.5 million kilometers, it joined its siblings, the Gaia and James Webb telescopes, in orbit around Lagrange Point 2. This location is ideal for studying and imaging deep space. It allows telescopes to keep the sun, moon, and Earth behind them at all times, so they never interfere with observations. It's also close enough to Earth that communications are easy. Since L2 keeps pace with Earth's orbit around the sun, we stay close to our instruments. Euclid's 6-year mission is designed to explore the composition and evolution of the universe. It will do this by building the largest and highest quality 3D map of the cosmos we've ever seen. In October 2024, Euclid started sending back the first pieces of this map. I'll show them to you in a second. As Euclid continues to scan the sky over the next years, scientists hope the new data will help them understand the role of gravity and dark matter in the structure and expansion of our universe. How it works first, you need to understand the 3 key things that make this telescope and its pictures so unique. Firstly, Euclid's ultra-wide lens captures more of the sky at once than any telescope ever has. It gathers high-resolution light data from billions of galaxies, some as far as 10 billion light-years away. Compared to ground-based surveys, it has 4 times the resolution and 15 times the sensitivity in the near-infrared. It can also spot objects hundreds of times fainter than the ones Gaia can detect. In a single observation, Euclid records vast cosmic structures and precise details of individual galaxies. The result? An image that conveys multiple cosmic scales at the same time, bringing home details in a way that makes researchers giddy. Secondly, Euclid measures subtle distortions in galaxy shapes caused by dark matter's gravitational influence, creating a gravitational lensing map. This is key to understanding how galaxy clusters grow and evolve, while also showing us how dark matter has played a role in literally shaping the universe. Finally, Euclid is creating a 3D map of the universe with 2 advanced instruments. The Visible Imaging System, VS, captures ultra-sharp images in visible light to measure galaxy shapes and positions, while the Near-Infrared Spectrometer and Photometer, NSP, measures redshifts, placing galaxies in 3D space. In short, Euclid is kind of a big deal. The hype in the astronomical community around these images is real, as summed up by one Euclid project scientist. We have never seen astronomical images like this before, containing so much detail. They are even more beautiful and sharp than we could have hoped for, showing us many previously unseen features in well-known areas of the nearby universe. René Lauriages, Euclid project scientist. So let me take you on a tour through Euclid's first light images one by one. Starting with our map. The Mosaic. Thanks to ESA's Gaia and Planck missions, we already have a pretty solid map of our Milky Way. Euclid is tasked with gathering data on the dark parts of the map. So far, it has covered about 1% of the map it was sent to create. Between March 25th and April 8th, 2024, Euclid took 260 pictures of the southern sky, covering an area 500 times the size of the full moon we see from Earth. Putting these pictures together, scientists created a mosaic spanning millions of stars and galaxies. And remember, this is just 1% of what it's planning to do. Because Euclid captures both big picture and detailed data at the same time, researchers can see the sky at different scales, From extragalactic views, we can zoom into galaxy clusters, their core, and even individual galaxies. So let's explore some of these cosmic structures, starting with one of the biggest known in the universe. Perseus Cluster. This is the Perseus Cluster located 240 million light-years from Earth. This image shows over 1,000 Perseus Cluster galaxies and more than 100,000 faraway galaxies in the background. Scientists think the way galaxies are organized can tell us a lot about the distribution of dark matter and dark energy. You see, gravity might cause dark matter to organize itself into filaments. We aren't sure, but NASA scientists believe it's possible that where these filaments intersect, galaxies stick closer together, forming a cluster. The theory goes that if there were no dark matter, galaxies would be distributed evenly throughout the universe, which obviously isn't the case. While many galaxies in the Perseus Cluster are already known, cosmological simulations predict there should be several dwarf galaxies there too. If we could see those faint galaxies, we could analyze their shape and distortion relative to the cluster and background to determine how dark matter is distributed. The problem is these dwarf galaxies tend to be overshadowed by older stars shining infrared light, so they've evaded direct observation until now. Euclid discovered more than 630 previously unknown dwarf galaxies, which is a huge breakthrough in the study of dark matter. More than dark matter, Euclid is also teaching us about star formation, too. Let's go to our next destination, and I'll show you. Irregular Galaxy NGC 6822. Say hello to Irregular Galaxy NGC 6822, shining bright 1.6 million light-years away. It was first identified as a remote stellar system by Edwin Hubble in 1925. Now, almost 100 years later, Euclid is sending back high-resolution images of the entire galaxy and its surroundings. The JWST did also image this galaxy a few years ago, but a much narrower field of view. Scientists are interested in Euclid's wide-angle photos of this galaxy for what they might tell us about star formation and the early universe. You see, stars smash lighter atoms like hydrogen and helium together to produce heavier atoms, including metals. This process happens across a star's lifespan, and is why we don't see many heavier elements in the early universe, because they take time to accumulate. Surprisingly, many of the stars in NGC 6822 have very low levels of metal atoms. By studying low metallicity galaxies like this one, scientists hope to learn more about how galaxies evolved in the early universe. Euclid has made that a monumentally easier task thanks to the color information from its NASB instrument and its wide field of view. Euclid has also revealed several previously unknown globular star clusters and HI regions in this galaxy. HI regions are the colorful gas clouds we see here. When stars are born, they emit light so strong and bright that it ionizes the hydrogen gas surrounding them, resulting in these HI regions. Studying these will help us better understand the cloud properties at the time a star is born and what conditions are needed for massive star formation. Globular Cluster NGC 6397. Speaking of globular clusters, here's one in a different part of the sky. Globular Cluster NGC 6397 is 7,800 light-years from home, making it the second closest one to us. This image is one part of a wider image from Euclid, which I'll show you in a little bit. Globular clusters are kind of like Hollywood, a high concentration of stars in one place, where everyone is trying to outshine everyone else. What does this mean? The smaller, dimmer stars get drowned out by the bigger, brighter ones. On top of that, they extend quite a long way out from their center, with the radial parts mainly made up of low-mass, faint stars that, until now, have been hard to see. Ironically, it is these faint stars that hold the most scientific interest for unlocking the history of the Milky Way. As Davide Massagri of the National Institute for Astrophysics in Italy puts it, currently no other telescope than Euclid can observe the entire globular cluster, and at the same time distinguish its faint stellar members in the outer regions from other cosmic sources. Hubble actually imaged the center of this cluster in 2021. But to image the entire cluster, including the sprawling outskirts like Euclid did, would have taken it far too much time and resources. On the other hand, Euclid snapped this shot in just 1 hour, and it is absolutely beautiful, both aesthetically and scientifically. Sometimes, we see stars arranged like this. and sometimes we see them arranged as spiral galaxies. Yet despite living in one, we don't actually know how they maintain their shape. The next Euclid pictures aim to help answer those questions. It's worth noting that the technology that allowed Euclid to capture these images wasn't cheap. ESA spent an incredible 1.4 billion euros on the development, construction, launch, and operation of Euclid. Anything that might have reduced that cost to get that data about our universe would have surely been welcome. Well, we might not be able to help with that, but if you're trying to see the sights around the Earth and are struggling to keep the costs of buying data down, the sponsor of today's video, Airalo, can help and are even offering a special $3 discount off their price if you use my code ASTROM3. Having data and SIM coverage when you're abroad is a must, as any frequent traveler will tell you. But roaming can be expensive. Airalo is an eSIM marketplace that lets you select an eSIM from over 200 different countries or regions at prices as much as 10x cheaper than you'd otherwise be paying. I found it super easy to set up in just a few minutes. And if you're still worried, you can reach out for help from their support team 24/7 for whatever little hiccups life might throw at you. If you want the peace of mind of knowing you've got data coverage sorted wherever you travel in the world for a low price, why not follow my link airalo.com/astromspace or scan my QR code to download the app. If you use my code ASTROM3 at checkout, you'll receive $3 off your first eSIM. Give it a try. The Hidden Galaxy, Caldwell 5, also known as the Hidden Galaxy, is hard to observe because it lies in the busy disk of our Milky Way, about 11 million light-years away. It tends to get overshadowed by dust, gas, and other stars. It is considered a look-alike galaxy to our own, which makes it a prime point of interest for researchers. It's pretty hard to study a galaxy you're inside of since you only get to observe it from one plane. Euclid's near-infrared instrument was able to pierce through the dust and reveal the galaxy in all its glory. We've captured it before from the ground, but with nowhere near the detail Euclid manages. The Euclid image might look normal, as if every telescope can make such an image, but that is not true. What's so special here is that we have a wide view covering the entire galaxy, but we can also zoom in to distinguish single stars and star clusters. We can trace the history of star formation and better understand how stars formed and evolved over the lifetime of the galaxy, says Euclid Consortium scientist Leslie Hunt. We still don't fully understand how spiral galaxies maintain their structure or the role dark matter plays in forming them. Euclid's ability to capture this galaxy's sprawling spiral arms and dust lanes in such detail will help scientists understand the link between dust, gas, and star formation on a large scale, in a way we've never been able to see before. Sadly, we've only got one more stop on this cosmic tour, but I've saved you the best for last. Let's see what these colorful clouds are hiding. The Horsehead Nebula. Our fifth and final photo shows the Horsehead Nebula. It has been photographed by various telescopes before, but never with such a sharp and wide view as Euclid managed. Again, this shot was taken in just 1 hour, which is absolutely mind-blowing. It's like someone just stopped at a viewpoint and snapped the picture. Located approximately 1,375 light-years away, this is the nearest massive star-forming region. It lies just south of Alnitak, the easternmost star in Orion's three-star belt, and is part of the expansive Orion molecular cloud. It is in this swirling nebula that scientists hope to find evidence of many previously unknown Jupiter-mass planets. One such planet has already been identified, Sori 62, a young planet 10 times the mass of Jupiter and a temperature of 1,200 degrees Celsius. The clouds behind the Horsehead are illuminated by UV radiation from nearby star Sigma Orionis, while the clouds of the Horsehead itself are made up of cold molecular hydrogen, which gives off barely any heat or light. This makes the Horsehead Nebula an interesting place to learn more about star formation, as scientists can observe and compare how stars form in dark versus bright clouds. Sigma Orionis is part of a group of stars called an open cluster, which researchers hope to get a more complete picture of with Euclid's data. For example, free-floating planets have been known to exist in Sigma Orionis. But with Euclid's ultra-high sensitivity, scientists found many smaller FFPs than were previously documented. As one research paper put it, FFPs in that zone appear to be ubiquitous and numerous. Just the beginning. This is just the beginning. With another 5.5 years of mission time left, Euclid still has a lot of ground to cover. Along the way, the data and images it collects will be pivotal to helping scientists unravel the mysteries of dark matter, dark energy, and the origins of stars, galaxies, and the universe itself. A 3D map of the distribution of dark matter could be revolutionary for our understanding of fundamental physics. Until then, we'll just have to entertain ourselves with more images as they come out. Thanks for watching. If you like this video, you may like my other videos on space tech and innovation. Did you hear about JAXA's precision landing on the moon? It has the potential to catapult us into a new era of planetary exploration, but it didn't totally go according to plan. Click here to watch it now. See you next time.